But here's the thing. The reality of this animal completely subverts that dramatic name. The myth implies, a blood-sucking squid suffering in some hellish environment.
So for decades, biologists simply couldn't agree on what this creature actually was. Some thought it was an octopus, while others were totally certain it was a squid. And honestly, the confusion was entirely understandable.
Just how extreme is this habitat? Well, the vampire squid lives in what's known as the oxygen minimum zone. In the eastern Pacific, dissolved oxygen can fall to a shocking 0.2 to 0.5 milliliters per liter of seawater. But you're probably wondering, how on earth does it breathe down there? Well, researchers like Brad Siebel and James Childress documented a trio of extraordinary physiological adaptations.
And that leads us to this really beautiful realization. Survival isn't about finding more oxygen. Sometimes it's about needing less.
Okay, this is where the vampire squid becomes truly spectacular. Since it can't use speed, it relies purely on an absolute arsenal of deception. First, it pulls its webbed coat upward and over its body. In the deep ocean, bioluminescence is communication, confusion, and defense. Biochemical reactions involving compounds like luciferin and luciferase.
And to navigate this crazy world of faint, glowing lights, you need incredible vision. Check out this number, 2.5 centimeters.
But almost everything about its name is completely misleading. Actually, scratch that. It's all misleading. It isn't actually a squid. It isn't a vampire in any biological sense whatsoever.
I mean, it has 8 arms, much like an octopus. But then it also shares specific anatomical characteristics with squids that octopuses just don't have.
To put that into perspective, for almost any other marine animal, that is a deadly, completely hostile environment. But for the vampire squid, it's a brilliant sanctuary. First up, it has extremely large gills with a really dense surface area to maximize oxygen extraction. Second, it uses this unique blue, copper-based hemocyanin blood that has a crazy high affinity for capturing oxygen, even when it's super scarce.
The vampire squid's ultimate evolutionary hack was to simply lower its metabolism so drastically that it transformed a deadly oxygen-deprived zone into a completely safe refuge.
Literally inverting itself into a dark, enclosed sphere, with its spiky projections pointing outwards. It's wild. Then it uses photophores across its body to emit light, transforming from a recognizable animal into a glowing, spinning sphere. Turn precious light into a vital survival tool. In a world with absolutely no sunlight, the ability to control light output, varying its intensity and patterns.
That is the diameter of the vampire squid's massive, vividly blue eyes. Now, on a body that's only 30 centimeters long, that proportion is absolutely huge.
And while it does live in an extreme, pitch-black and oxygen-deprived environment, it definitely doesn't suffer. It absolutely thrives there.
Yet, throwing a wrench into the whole shebang, it possesses 2 highly modified sensory filaments that don't fit neatly into either category. It was like a giant biological puzzle.
Why? Because this massive lack of oxygen naturally excludes almost all major predators and competitors. And third, and this is the real game changer, it possesses an exceptionally low metabolic rate, significantly below that of similarly sized squids and octopuses.
It wasn't about fighting for more oxygen. It was about evolving to need less of it.
And if that's somehow not enough, it can release actual clouds of bioluminescent decoy mucus from the tips of its arms. It leaves this glowing target behind while it just quietly slips away into the dark. Turns bioluminescence into the ultimate multi-tool for staying alive.
A larger eye aperture allows this animal to collect super sparse photons and detect even the absolute faintest bioluminescent signals from predators or decoys in the abyss.
Of course, navigating this shadowy world requires some highly specialized vision. And it turns out the vampire squid possesses the largest eye-to-body ratio of any animal on Earth. Its eyes are astonishingly massive, with a vivid blue iris and a gigantic dark pupil. When you're in near-total darkness, having massive eyes is all about aperture physics. That giant pupil maximizes the rate at which sparse, scattered photons can actually reach the retina, which allows the squid to detect even the faintest glimmers of bioluminescence from predators or its surroundings. The Latin name Chun gave this unsettling discovery, Vampyroteuthis infernalis. Literally translated, that's the vampire squid from hell. Sounds like total nightmare fuel, right? But here's the crazy part. In biological reality, we can completely cross out vampire, scratch out squid, and definitely cross out from hell. This animal is actually the ancient sole survivor of its own evolutionary order. It's just a gentle, passive particle eater that slowly drifts through the ocean. That terrifying name? It's a total myth, just a historical misunderstanding of a truly incredible survivor. So, you're probably wondering, how on earth does our creature survive here? Well, it relies on an absolute physiological masterclass in oxygen extraction. First off, it has a dramatically expanded gill's surface area that's just packed with an incredibly high density of microscopic lamellae. That helps it squeeze out every last drop of oxygen from the water. Plus, the vampire squid has blue copper-based blood. This blood contains a specialized, highly modified variant of a protein called hemocyanin, which has an unusually high oxygen affinity. Basically, it acts like a super sponge, snatching up and holding on to oxygen at incredibly low concentrations where standard molecules would completely fail. But the defense doesn't stop at just changing its shape. Oh no. As it forms that spiny sphere, it simultaneously fires up over 25 synchronized photophores dotted all across its body. Thanks to some amazing cellular chemistry, where a molecule called luciferin is oxidized by an enzyme called luciferase, it produces this cold blue-green light. It essentially turns into a glowing, flashing, spinning disco ball in the pitch black. And if that isn't confusing enough, it has one final magic trick. Standard squids use ink, right? But ink is totally useless in the dark, so instead, the vampire squid releases a cloud of glowing, sticky, bioluminescent mucus from its arm tips. This creates a brilliant decoy light that the predator attacks, while our squid just quietly slips away into the shadows.
But hey, if the bluff doesn't work, it has to rely on some other tricks. Up in shallow water, a regular squid will shoot a massive, dark cloud of ink and use a high-speed jetting escape to get away. But down in the deep water, a dark ink cloud is literally useless when it's already completely black. There's no light for the ink to block. So the vampire squid had to evolve a completely different, highly specialized strategy to escape. Well, what's genuinely fascinating here is that this animal is essentially an evolutionary relic. It belongs to the order Vampyromorphida, and get this, it is the sole living species recognized in its entire lineage today. So while it is related to modern squids and octopuses, it actually belongs to neither group in the ordinary sense. It is held onto a totally distinct combination of anatomical traits. Instead of furiously jetting around like the typical squids you see in shallow water, it has this incredibly soft, gelatinous body and just swims gently using those little paired fins.
And this is the massive contradiction we're exploring today. The myth tells us we're looking at a blood-sucking, hellish beast completely covered in spikes, just aggressively hunting down whatever it can find. But the reality? It's honestly completely different. Despite looking like a total monster, it doesn't drink a drop of blood, it definitely doesn't hunt humans, and it actually just feeds on floating ocean garbage. It's really just a peaceful survivor trying to get by. Plus, technically speaking, it isn't even a true squid.
Less than 0.5 milliliters per liter. That tiny number is the harsh reality of the vampire squid's home. At 700 meters down, there's a distinct band in the water column called the oxygen minimum zone. Down there, dissolved oxygen levels completely plummet. To put that into perspective for you, most predatory fish and large invertebrates absolutely need at least 1 full milliliter per liter just to survive. So this band is effectively a dead zone. It is completely uninhabitable for most of the ocean's predators.
But you know, despite everything we've learned, there is still just so much we don't know. The biggest remaining mystery is that reproduction has never been directly observed. Evidence actually suggests females might undergo multiple reproductive cycles over their lives. That's incredibly unusual for cephalopods, and it could imply a surprisingly long lifespan. This lingering unknown just adds even more to the alluring mystique of the animal, don't you think?
Vampire squid perfectly reminds us that in the deep ocean, survival isn't about being the most vicious, scary monster. It's about being the most adaptable. Which makes you wonder, what other alien survival strategies are hiding just out of our reach in the blackness of the abyss? This guy is just one member of an underwater world that creates its own spectacular light. So make sure to hit that subscribe button to join us for our next explainer, where we're going to dive even deeper into the strange, glowing world of underwater bioluminescence. You definitely won't want to miss it.